All right, this is the fourth and final part of this epic Google Doc from week 1, quarter 4. All right, so on your Google Doc, you're going to see your data. Sadly, I can't give you actual candy for a number of reasons. 1, I just had a baby. 2, probably no one's giving you candy because even if you're in the building, we're not supposed to be like sharing objects and passing things back and forth and stuff. So it's just going to be sad pretending. Okay, so I gave you each 50 Skittles and 50 M&Ms. So kind of me, right? Here are the pretend numbers of orange Skittles you got and orange M&Ms. So just go find your name. It'll tell you how many orange Skittles and orange M&Ms you pretend got in your pretend candy. So sad, right? I know. All right, so for your data, I want you to calculate the proportion of orange candies in each sample and find the difference between proportions. So if you don't know what I mean, let's say that my data was like, I'm just gonna make some stuff up. Let's see where it says Beth. Let's say I had like 12 for, what's the first column? For Skittles and 10 for M&Ms. Each sample was out of 50. So if I'm finding my proportions for Skittles, I'm gonna do 12 out of 50 and that's gonna give me 0.24. And then for M&Ms, it's going to be 10 out of 50, which is going to give me 0.20. Then it's asking me to subtract the proportion. So I'm going to do 0.24 minus 0.20, and that's going to give me 0.04. So I need all of you to go ahead and do this for your data. You're going to have different numbers than me, pretty sure. See if anyone else has 12 and 10. Mara, you do, so there you go. Everyone else other than Mara should have different numbers here. All right, so again, since we're not together, it's not in my, well, you have this on your doc. There's a dot plot. If we actually did make a class dot plot of the differences, it would look something like this. I went through and I actually calculated all of the differences for all of those proportions, and so you should see your data there. If not, either you did something wrong or I did something wrong. So you can check your work because I'm making this on March 24th. I'm not going to check my work at this point. All right, so question 3, telling us what does each dot represent here? I feel like I keep asking you the versions of the same question. Except for this is a little different because we're looking at differences. Each dot tells you the difference in proportions of orange candies for one sample of Skittles and one sample of M&Ms. All right, so I want us now to go ahead and make some estimates here. Make a prediction. What do you think the shape is? What do you think the center is? What do you think the variability might be? And we're making some guesses here, and that's okay. All right, so go ahead and pause if you haven't, and then when you're ready, hit play. For shape, to me, this looks approximately normal. Man, I really wish I would have put a screenshot of the graph on my PowerPoint, but I didn't. It's okay. Looking at it, it looks like the mean is like, maybe like negative 0.25-ish. I don't know. Just trying to estimate where, not negative 0.25, negative 0.025. Yes, that's what I meant to say. Your estimate can be a little bit different from mine. It's just kind of eyeballing it. And then looking at our standard deviation, just a quick reminder on standard deviations. 68% of your data has to fit within one standard deviation of the mean. So just trying to estimate where that might be. It looks like maybe, I don't know, maybe around 0.05. These are just estimates. We'll get our specific values in a bit once we get some formulas. All right, let's keep going. A Google search reveals that 21.6% of Skittles are orange and 20% of M&Ms are orange. So we're going to assume these claims are true, that they describe accurately the population. So P, no hat, just regular P, I'm going to do a subscript of S to show for Skittles, is 0.216, and P sub M for M&Ms is 0.20. All right, so here it's asking us a whole bunch of stuff. Describe the sampling distribution of the sample proportion of orange for Skittles, and the same thing for M&Ms for samples of size 50. Okay, so let's see if these are, okay, so first of all, we want to check for large counts. I wish I would have given myself a lot more space to write here. That's okay, it's all good. Okay, if I am looking at just one sample, which I am here, for shape, I want to look to see if the large counts condition is met. For the mean, this comes back to the last part. The mean of the samples is going to be equal to the true population proportion. I said the wrong thing. The proportion from the samples is going to be equal to the overall proportion. And then standard deviation, I'll give you the formula for that here. So I want to give you a minute to go ahead and try to fill this out. Fill out this table, get as far as you can. If you get stuck, make a mistake, it's all good, but give it a shot and then we'll go over it when you're ready. All right, I'm just trying to give myself some more space to work because I did not give myself any room. Can I quickly make this let's do light yellow. Okay. All right, so for shape, we're gonna check to see if the large counts condition is met. So for Skittles, if I have 50 Skittles, and 0.216 of them are orange, that's going to give me 10.8 expected value orange Skittles. For not orange, that's going to be 1 minus 0.216, also times 50, that's going to be 39.2. Both are greater than or equal to 10. And so what that tells us about the shape is that it's approximately normal. This stuff is what should be going right up here. All right, for our mean, it's going to be equal to, I'm going to write out this whole thing. I know the notation is kind of hard to use on Google Docs, so don't stress too much about it. It's going to be equal to my population parameter mean, which is 0.216. That is what goes here. And then my standard deviation, I have a nice formula to use for that. Oh, and my S here is just standing for Skittles. Don't stress too much about that. Okay, so let's see, 0.216 times 1 minus that, which is 0.784, all divided by 50. And that's going to give me my standard deviation of 0.0582. And that is going right here. Sorry, I know that looks really crazy with all the arrows. Sometimes I just have to check to make sure I'm actually recording because that would just be really sad. All right, for M&Ms, we're gonna do the same thing. I'd encourage you to pause and try M&Ms. Like if Skittles confused you, maybe now that you've seen me do that, maybe you can do M&Ms on your own. Maybe you already tried it, you're ready to go over it. Either way, here we go. For M&Ms, first of all, we're gonna check to see if the large counts condition is met. So 50 times 0.2 is gonna give me 10, which is greater than or equal to 10. Yes, barely. Okay, 50 times 0.8 is 40. That is also greater than or equal to 10. Cool. That means it's approximately normal. Okay, for our mean, it's going to be equal to our population mean, which is 0.2. And then for our standard deviation, I'm going to do 0.2 times 0.8 for my numerator divided by 50, all under a square root, which gives me 0.0565. All right, we're now going to be looking at describing the sampling distribution of the difference between proportions of orange Skittles and orange M&Ms. So what we're seeing right here with all these crazy arrows and everything is looking at each kind of candy independently. In question 6, we're looking at both samples at the same time. Not both samples, both kinds of candy at the same time. I've just been recording these videos like back to back, so I just had to drink some water. Whew, okay. All right. So we already did this. I just duplicated my slides so I'd have space to write. Okay, so the shape here, I'm just wondering if I actually want to jump to notes first. I think I do. Okay, so we're going to do some notes and then come back. So just because I feel like otherwise, like, how would you know how to do this? If we're looking at the sampling distribution of two different samples, proportions, and we're finding the difference between them. So this is what we're doing here. We're looking at the proportion of orange Skittles minus the proportion of orange M&Ms. So for the shape, we can go ahead and check for normality. So it's going to be approximately normal if within both kinds of candy, the large counts condition is met. So N1 times P1 is greater than or equal to 10, and N1 times 1 minus P1 is greater than or equal to 10. I'll explain all of this in context of our problem in just a second. N2 times P2 is greater than or equal to 10, and N2 times 1 minus P2 is greater than or equal to 10. Basically, what this means in terms of the problem we're working on is if we would expect to see at least 10 orange M&Ms, at least 10 non-orange M&Ms, at least 10 orange Skittles, and at least 10 non-orange Skittles, if all of those are true, we can go ahead and say that it will be approximately normal. For the center, it's going to be the mean, and then basically this is just asking us what's the center in notation, but to calculate it, you're just going to take your population proportions and subtract them, so that's actually pretty straightforward. I'm going to save this for a bit. Variability, we're going to use standard deviation here. And here we go. This is fun. Big square root. Get ready. It's going to be basically we're going to calculate it the standard deviation for the first part, and then also for the second part, we're going to add them up and take the square root. So based off of that, I'd like you to try to, I'll go back to the notes in a sec, try to do this. And also try 7. I actually have to stop this video early because I have to go to a meeting, but I will finish this up. So this is a 2-parter, but so there's a little cliffhanger. But try to do 6 and 7, and then, yeah, we'll go from there. Bye.